Right. Today I will talk about the brief introductions to the string theory, especially the superstring. Because I'm not expert in the theoretical particle physics rather than the theoretical ones that I focus on the phenomenology, but this is for the just a brief introduction, so the maybe the some things along and just overviews for the string theory. So the historically the string theories are motivated by the hadron, like the Cork model. Um, Instead of the point particle, the one-dimensional string structures or objects are introduced, especially to explain the combinations from the quantum and gravity theory at the Planck scale, which is the 10 to the 19 GeVs, and the corresponds length scale is 10 to the minus 35 meters. And as a result of the string theory, the spectrums that gives the spin to particle which correspond to the gravitons, and especially the to reduce the dimensions, the supersymmetric versions of the string is helpful, and the one important characteristic of the string theory is the divergence split theory due to the renormalizations with the point particle gives the UV divergence in the loop diagram. It because we integrate over the momentum space to the some specific UV scale, and that is scale go to the infinity. But in the one-dimensional string object case, such a divergence from the UV scale can be avoided. So the string can be represented by the following form, especially the bosonic string. The string lives on some specific space, d minus one partial dimensions, and over the time. This x mu is called a string variable. And these string variables are embedded in the d-dimensional space-time. And if we know that some specific object like the string, then we can construct the Lagrangian action is called a string action. The string action is proportional to the string surface swap, the area component, and there will be some constant which is correspond to the string tension. And if the string swap the specific surfaces, called the world seat, string moves over some specific time. And this action should be the invariant under the reparametrizations of the coordinate. This is correspond to the diffeomorphism of the general relativity theory. The transformations changes from the space-time sigma and tau to the sigma prime and the tau prime. And there is additional invariance, the first one is the Lorentz invariance from the spatial relativity theory, and the scale invariance, which is the same to the conformal symmetry in the two dimension. Such invariance of the Lorentz and the scale one implies the existence of the energy momentum tensor by the Noether theorem. And we can classify some specific string, like the open string. The endpoints and the starting points are different, but if the endpoint and the starting points are same, it is called a closed string. And for the 1 plus 1D string, the 2D string, the coordinate transformations, they can be noticed like that. The QC plus correspond to the coordinate, and the delta n is correspond to some specific transformation. Then we can expand this transformation in infinitesimally nearby this identity. Then there will be the smaller parameters and generate this is the same form to the Lie algebra. And if we construct the Lie algebra, we need to know the commutator relation. So the commutator relation between the generator Ln and Lm is given by the Virasoro's algebra. And this is just a classical version. If we add the quantum correction, then there will be the anomalous effect, which make the additional terms so-called the central charges. So the 1 plus 1D, the 2D string action can be written by the following form: the tension, area, and there's kinetic terms forms for the string variable. And we can obtain the string stress tenses from the invariance, um, from the diffeomorphism, the coordinate transformation, and the scale, which is the same conformal symmetry in the two dimension. So the stress tensor has the following form. This is also can be obtained by the Noether theorem. And by the some transformation, we can obtain the generated Elan, which is satisfied the Virasoro algebra dimension. And in the quantum level, there will be the central charges that appear. And such a central charges is equal to the d for the d-dimensional space-time. If we consider the gauge fixing and the ghost, like as the Popov's techniques in the quantum field theory, then the ghost contributes the central charges to the minus 26. So total central charges is given by the original one, d and minus 26 from the ghost. And we want to make the anomalous free, so the total central charge should be balanced. So to make the anomaly free theory, the dimensions of the space-time for the bosonic string should be the 26. It demands the compactifies the extra dimension. But in the superstring case, including the fermion partner, the ghost contribution to the central charges becomes the minus 10. And this makes the superstring theory demands the 10-dimensional extra dimension. And we can obtain the other approach for such extra dimension. For the bosonic string, we can obtain some mass eigenvalue from the momentum operator. And by the normal ordering of the ladder operator, and there is some additional vacuum energy from the Virasoro operator. Then the ballistic excited state correspond to the normal ordering of the ladder operator. Such a ballistic excited state should correspond to the massless state. And such a vacuum energy term becomes the minus d minus 2 over the 24 by the regularizations, like as the quantum theory box in the loop diagrams of the quantum wave theory. So to solve the right hand side, this combination, and the left hand side as the mass should be the zero, so that this yield the d equal to the 26, the same result from the central charges approach. And also we can obtain the other excited state, the mass spectrum, and for the superstring case, including the fermionic string, the normal ordering part for the ballistic excited state give the 1/2, because fermionic strings constructs with the commutators of the operators, and the vacuum energy gives like that. This gives the extra dimensions as a 10 dimension. And there are two types of the fermionic string, Anna string and the Lemon string, with a different periodic condition, anti-periodic and the periodic ones, and each of them gives the bosonic or fermionic spectrum. So here are some of the remarks. The open string gives a spin 1 particle, but there are no spin 2 particle. Closed string gives a spin 2 particle, but there are no Yang-Mills field, no gauge bosons associated to the non-abelian gauge theory. But at heteroteric string, there are both spin 1 and spin 2 particle. And also for the high-dimensional theory, this is motivated by the Color-Klein theory. The extra dimensions are compactified manifold, and such a compactified manifold gives the gauge matrix, which is aroused automatically. For example, if the space-time, the bind dimensions are under one dimensions that are compactified, then the U1 gauge matrix aroused automatically. So, as a similar logic, the bosonic string theory has a 26 dimension, and if we compact to the 10 dimension, then the 16 dimension gauge groups so arise like as E8 or as 32. And this corresponds to gauge boson like the graviton dilaton such a thing. And our world is a four-dimensional space-time, so there is a more six-dimensional compactification. So the point is the compactification sort of space yield the complex manifold like as a Calabi-Yau manifold, and this can be classified some topology techniques or called Moses. So here is our journey for the introduction of string theory. Because I'm not expert in this one, so I don't know the detail, but I want to overview just brief introduction of this and how the string and the extra dimension and the superstring gravitons arise thing. So string moves over space-time. This gives the world seat, and this has a Laplace materialization and the scaling invariance corresponds to the diffeomorphism and the conformal invariance, and we can construct the Virasoro algebra to correspond to this transformation, and this gives the extra dimensions automatically by considering the central charge estimated in the quantum level or considering the mass spectrums corresponding to the generator. And because our world is a four-dimensional, so the remaining dimensional space should be compactified, and this gives some specific complex manifold, the point-table geometry, and the compactified space correspond to the gauge group, and the graviton and the gravitinous automatically arise. And if we consider the post-metric version, including the parameters of operators such the number of the extra dimension can be reduced. But the problem of the string theory is how to test the prediction due to the very high energy scale of the Planck one.